Welcome to Spring LIB.
Hi there, so for this problem we have a television and radio waves reflecting from mountains or airplanes can interfere with the direct signal from the station. So for part A of this problem, the question is what kind of interference will occur when a 75 MHz television signals arrive at a receiver directly from a distant station and are reflected from a nearby airplane that is 122 meters directly above the receiver. So with that said, we have the situation that is shown here in this figure. Now, first of all, we know that the wavelength of the signal is equal to the speed of light, this divided by the frequency. So that will be 3 times 10 to the 8 for the speed of light in units of meters per second, divided by the frequency that we are given for this, which is 75 times 10 to the 6 hertz. So from this, we obtain that the wavelength is equal to 4 meters. Now, for part A of this problem, we know that there is a phase difference between the direct and reflected signals. From both the path difference, that is going to be that path difference, as you can see from the figure, is h divided by the wavelength, and this times 2 times pi, and the reflection pi. So the total phase difference that we're going to label as V is then h divided by lambda, this times 2 times pi, and this plus pi. So now we substitute the values for this. So we know that h is 122 meters, this divided by the wavelength that we obtained from before, that is 4, this times 2 times pi, this plus pi. And with this, we will obtain that this is equal to 62 times pi, which is the same as 31 times 2 times pi, okay? Since the phase difference is an integer multiple of 2 times pi, the interference is then constructive. So that's a solution for this problem. The interference is constructive. Now, for part B of this problem, the question is about what kind of interference will occur if the plane is 22 feet closer to the receiver. Now, when the plane is 22 meters closer to the receiver, the phase difference is as follows. So now phi is equal to h minus y, this divided by the wavelength, and this times 2 times pi, and this plus pi. So in here, if we substitute the values, we will have that this is 122 minus 22, this divided by 4, and this times 2 times pi plus pi. So the value that we obtain from this is 51 times pi. We can write this as 51 divided by 2 times pi. Now, since the phase difference is an odd half integer multiple of 2 times pi, then the interference is destructive. So that's a solution for this problem. Thank you.